Hey, minasan, konnichiwa, Zamurai Engineer desu. So again, let us get on our discussion of principles of reinforced concrete. So let us get back to the computer examples. We already taken the manual examples, and now I will show you how can we be able to make an application program for the problem solving using computer solutions, okay, solving by computer rather than by hand. Okay, so let us start with the computer example that I already showed you, and I open up the Excel. I open an Excel, so you can do it with me. So you can join, open your own Excel, and let us do it at the same time. So recall that we have example by repeating example 1 using spreadsheet. So we already done the opening of Excel. So take note, we have the given values 4,000, 25, 12, 18, 145, and 1. So the first thing we have to compute is this one. This is moment of inertia. Okay, inertia. So let us recall FC prime. Okay. So how to make FC prime MB? So here we can make input values. Input values. Okay, so first one is FC prime. So FC prime. So we can make this a little bit bigger. Okay, so a little bit bigger. So input values, we have, for example, bold. Okay, so we can also use a different type of let us use our favorite font. So next we have M, then D. So what are those values? So let us check MB. What is this? H. Then YC lambda. H symbol. This is what symbol is this? Insert symbol. Insert the symbol. So look up for the symbols. More symbols. Use the Greek letter. Let us search for the Greek letter. Oh, that is the Greek letter that we have. Well, which one? I think we have here this one and this one. I think this one. We are using this letter, but this look like Y, no? That looks like Y. Anyway, I think that is what we are looking for. And next one, so only, okay, that's correct, but we are actually using what? The type of font, that's why it looks like Y. That is not Y. That is a Greek letter. So again, we insert lambda here. So another Greek letter, lambda. So where is the lambda? Lambda. Here, this is the lambda. Okay. So insert lambda close. Okay. So we are okay with what? 1, 2, 3, 4, 5, 6. So there are 6 input values on that example. So let us do this. So we have to input the values here. Okay, so let us color this as yellow. That is a color that is not good for the eyes. So let us make it a little bit better. So let us put the box. Okay. Then put the necessary unit of measure so that the one who will use this program will know what unit must be inputted. So PSI, for example, PSI fit K, something like that. PSI must be used here. Then next is fit K. Then next is inch. Then height is inch. Then YC. So that is actually density. This is density, right? PCF. So PCF means pounds per cubic foot. So this is YC. So meaning density of concrete. So this is about density of concrete. So can we do it, sub, what is, can we do it? Okay, so something like that. Okay, then next is what? Lambda. There is no dimension. So lambda, no dimension, so just put like that. So because there is no dimension, so put like that. Okay. It cannot be done. So I don't know how. So I think I have to do this. Okay. Cannot be done. So I don't know how to do it. So just erase it. So none. There's no dimension for lambda. So output. So the computed values. Computed values. Okay. So we have the following. What are the computed values? IG, FR, F, okay? IG, FR, F, What else? MCR. Why there are two MCR? MCR. Oh, so MCR for different units. Okay, so MCR. Okay. So MCR and another MCR. Okay. So there are two different units here. So the answers, we should come up with an answer. So let us color the answer as our, okay. So let us put also the box. So let us put the legend. So meaning given data, this is required for us to be computed. Required result. Okay, so that's what we mean by that. Uh, this is our legend. Okay. So, for example, let us input the following given. What are the given values? 4,000, 25, 12, 18. 4,000, 25, 18. Are we okay? 4,000, 25, 12, 18 pa. 12 and 18. So 12 and 18. Then 145, then 1. 145 and 1.0. So 1, we can make it, okay, 1.0. So these are the given. So how to compute? So what are the result first? So the result is inch to the fourth power. So inch to the fourth power. The fourth power. What else? PSI. So we have PSI, and this is what? Inch pound feet K. So inch pound and then feet K. These are the units. Okay. So let us first compute the values for problem number 1. So let's go back to problem number 1. So this is our problem number. This is problem number 1. So how did we arrive at the answers? So IG. So use this formula. So let us just choose that formula. Bh cube over 12. So let us go back to our Excel. So put an equal sign, then B. So here times what? H raised to the third power. So then all of this divide by 12. All of them have to be divided by 12. Enter. So the answer is 5,832. So what is the answer? Here, 5,832. Okay? So the same. So we are able to do that. So therefore, later on, changing these values will enable you to have the computer solution. Okay? So, okay? So take note. Please do not use this as a cheat. Okay? Do it by yourself and then you will understand. If you are relying on the computer solution, when there is a small changes that is critical, you will not be able to compute it. What is the next? FR. How do you find FR? So, we're just multiplying here. Here is the formula. So, 7.5 times lambda. Okay. So, FR is equal to, put the equal sign, times 7.5 multiplied by lambda, and then multiply by, okay, this is multiplied by lambda, then multiply by square root is QRT. So put the square root is QRT. Square root of what? Square root of this one. So enter. So the answer is 474. Is that correct? So here is 474 PSI. So let us click this several times. So 474 PSI. Okay. So what about F? How to solve for F? Use here the formula here. My over Ig. So equal sign. So my. Okay. So multiply the conversion factor. How much is the conversion factor? Times 12. Times 12. Okay. Because this is in feet. So we have to make it in inches. No? My. Where is the Y? My meaning multiply this by my is 9 in this example. My is okay, 9. Why we are using 9? Divide by what we found as Ig. Okay. Okay. Why we have 9? Okay. So let us multiply by 9. Divide by Ig. Where is Ig? This one. And enter. Is this correct? The value is must be multiplied by 1000. must be multiplied by 1,000. 1,000. Okay, so let us click this one several times. So 463. So is the answer 463? So 463. Okay. Okay, so 9 here is actually at the center of 18. So we have to use that 18. Okay, so here we use 9, but 9 is actually equal to 18 divided 2 at the middle, at the center, because we are looking at the what neutral axis, and neutral axis is at the center, okay, at the middle. Okay, take a look. Why the neutral axis is at the middle? Because this is not uncracked model. There is no crack, and we have to what? We have to disregard, or this is negligible. The reinforcement are negligible because the situation is stage 1. Stage 1 uncracked, negligible reinforcement. That's why we have this. 9 is 8 divided 2. So 18 divided 2 is 9. Okay? At the center. Okay? So how to compute MCR? So just again, substitute the values. Okay? We have a par FIY over I. Okay? FY. So put the equal sign. F, this one, then multiply by I, and then divide by this one, divide by 2. Okay, that is our Y. So our answer is 307,000. Is that true? 307,000. This one, 307,152. So 307,373. So therefore, as you can notice, the correct number is 307,000. But 307,000 is 3 significant figures. That's why we have to use our 3 significant figures. Because this is now a result, we have to use 3 significant figures. Okay? So it cannot be done. So let us how to make it 3 significant figures. So, okay. So this must be 3 significant figures, but we cannot do it because how to do it? I don't know how, because I know we can do this thing, but it is not functioning well. No? So I think we have to do this somewhere else. Copy, then put it here. For example, put it here. So that is what? B11, B10, B5. So let us B11, okay. So if we already know that, therefore we can equal, and then Okay. So, undo. Is there an undo? Undo. Let us divide this by 1,000. Divide by 1,000. Oh, this is our answer, 307. Now, so put it back here. So putting it back here by doing this. Okay, and then multiply by 1,000. Okay? It will go back. No? So it cannot be done in this type of. I thought it would not be giving up the figures more than 3 significant. So this is not possible. So I think we can do this and just use that value. Okay, we cannot do it like that. I don't know how. I know, but I don't know how it should be done. I know there is a Excel procedure for that. But now we should just divide by 12,000. Divide by 12,000 so that we have what? Alala. So this is not divided by 12,000. So this one is the divide by 12,000 equals this one divide by 12,000. Okay, so that's why the answer is 2 significant digits. So let us give another digit. So 25.6. Okay, so the answer should be 25.6, which is the answer of the book. Okay, so that's all. So that's all for doing the computer application. So if you use this in other set of problem, it will automatically make the computation. You just have to input the values for this. Okay. So this is for what? Singly reinforced beam. For example, you make this 3,000. So it will automatically change the computation here. Okay. So this one and the final answer. Okay. So the automatically compute. Any question about this? So I would like to save this. You may like to save this. Okay, so that's how we do it using Excel as a spreadsheet. Again, everyone, thank you for attending our class. This is your professor, Dr. AP, preaching engineering for nation building. Thank you.